All right.
445.
445.
Numbers and 66 and 72.
I like that. Get a lot of bang for your buck. I got you in a second. Oh, I like that. Solve for x. Make up your own equation. So page 4.
445.
445.
And numbers 60,
Number 60.
66,
Oh, okay.
and 72.
I think 7.4 we just barely got into. So I still need to cover 7.4. Hopefully in the way we'll answer the questions. Cool. So you're just a little ahead, which is good. Dave, you had a...
Yes. 6.5, question 72 on page 397.
72?
Yes.
Cool. I would like this one, wouldn't I? I don't know if anybody would do this, but why can't you just cancel out the squares? You know why hopefully nobody would even think of doing that. But you can't. What do you have to do first when you're trying to solve an equation that has these kind of things in it? Distribute. I love it. All right, so it's distributed, it's FOIL, but it's still based on the distributive property. So almost always when you're solving equations, the first step is distribute somewhere. So you can free everything up so you can move stuff around. So when I distribute this, I have to write it twice. Not going to attack it, right? That's what squared means. That's what squared means.
Yeah.
So now I can FOIL those bad boys out. How we doing so far? Okay, and this makes sense. We know that when I give you an equation, the first thing you do is like a 3 in front of an x minus 1, you distribute it through, so you free things up, so you're able to move them around and put them with their like terms. Nothing different here, really. It's just I'm going to end up with a bunch of x squares, which is going to tell me to do what eventually when I have an x squared in an equation. What do I want to make it equal to? Shoot, I was hoping you'd get it when I said that.
0?
0, yes. When I have a higher power than 1 on my variable, I want to equal it to 0, so then I can factor and go from there, right? Okay, all right. No reaction at all. Not even a what? All right, so what do you get when you FOIL this thing out here? X squared. Minus 7, so minus 14. Is that cool? Just to cut to the chase a little bit. And then, of course,
49.
plus 49, I love it. And this, much the same way, this will be x squared plus x is plus 2x. Plus 1 there at the end. So that's not too bad. All right, so now what do you do to keep solving this? The next step.
Would you do like terms, or would
Yeah,
you
like terms.
subtract it first?
Well, like terms normally first. Try to simplify each side. But one thing you can notice here possibly is that one of the x squares would cancel with that. Do you see that? You could subtract an x squared. So if you happen to see that, do it. Because if you subtract x squared, those are both gone.
And the 2x and the 14x.
Well, now you can start more specifically moving stuff over. So minus 2x. And again, you guys just told me we have to do this after a little bit of prodding for me. If there's a power on your variable higher than 1, you've got to get it equal to 0. So then you can do that last step of factoring and go from there. So what do you get here?
X squared minus 14 is 16x.
Minus 16.
48 equals
0.
0. Cool. Oh yeah. And then the next to last step.
Is it 2 parentheses?
I love it. So the whole idea, if that wasn't there, I would of course subtract 48, divide by negative 16, because I can get x by itself. That's there, that sucks. Because I can't put my x stuff together. There's no way to get x by itself directly. So I have to do it indirectly. I have to break this guy up into parts. So what would those parts be?
Negative 14,
Well,
negative
Well, 14 times 2 is 28. Not quite enough. 12 and 4, good, we'll make 16, right? And they multiply to be 48. And they both have to be negative. So x is what?
12.
12, or x is
4.
4. I love it. Are you guys cool with that last step? Yeah.
Now, how'd you get the 12 and the 4?
So what really is happening there?
You have to add and then times it?
What's really happening here is if I have something times something is 0, what's got to be true? Either this first guy is 0, or this second guy is 0. The only way for two numbers to multiply to be 0 is if one of them is 0, at least. So either this guy is 0, or that guy is 0. So another way to look at this is, let me see if you guys understand. I have control over the x. So I can make this piece become 0, and I can see, well, what would make that piece become 0? Well, x equal to 12. But I have a whole other dude here. I have a whole other way, a whole other little thing I can control. How can I make this piece become 0? By letting x equal to 4. That's why I get two answers, because there's two different ways to make the whole thing come out to be 0. I can make that piece 0, which would kill him no matter what the hell he is. Or make that piece 0, which would kill him no matter what the hell he is. So if I make x 4, I get 4 minus 12 is negative 8 times 0. So the whole thing goes to 0. So that's the idea. I get two answers because there's two different ways to make this happen. And I can see those two ways when I break it up into parts. Okay. I guess no reaction is better than a bad reaction. I guess I'll take that. Oh, there's some good reaction. I like it. How do you check these? Plug them back in way at the beginning. Because you might have made a mistake anywhere in here. It might work here, but it might not work there. So you always plug it back in at the beginning. Cool. Any other questions from?
7.1 now. 75 on page 426.
You said 75, right?
Yes.
Where'd it go? There it is. Now, please, dear God, nobody do this. You cannot cancel some b's out here, right? Why not?
Because subtraction.
Yeah, division does not cancel parts of subtraction, but it just doesn't have that ability. Addition could do that, but not subtraction. Division, I can't do that. I can't break into the subtraction problem with division. So what's the first step, of course, on this? The first step in almost everything in chapter 7 is to do what?
Foil.
Factor. Well, unfoil, yeah, factor.
Yeah.
Because then I can see the parts and I can see who's common. I can kill the common pieces. So let's do the bottom first, maybe. Yeah, a squared minus b squared. That's a typical thank God problem. 2a, so I put in an a and an a. 2b, so I put a b and a b to make the middle term cancel. Minus plus or plus minus. What's the top? What form is the top in? There's no GCF up there, right? One's got B's and the other one's got A's. It's definitely a cubes. I can cut it in 3 pieces. So B, exactly. BBB, AAA. So little dude, big dude. What goes in the little dude? b minus a, and then b squared plus ab, I love it, plus this times this, a squared, I love it. Okay. So again, the bottom line, you know, I'm going to say this until we're sick of me saying this. If you can't factor, you can't do chapter 7, period. Because the first step in most of the problems is factor. Now tell me this. Something looks like it wants to cancel, but you can only cancel those things that are exactly the same. So what looks like it wants to cancel?
The b minus a.
Yeah, these are almost the same. Why are they different?
Because they're switched around.
Yeah, they're switched around. Here the b is positive, here the b is
Negative.
here the a is positive, there the a is negative. So how do you make the signs change?
You
So that you can cancel them.
No.
Nobody has a negative power, so nobody can flip. How do you change the signs in something? You take out a negative. So if I took a negative out of the top, what happens? The a becomes positive, and the b becomes negative. Let me just stop right there for a second. If you take a negative out of something, and we know this from grouping. Don't we know this from grouping? When the second guy is all negative, I take a negative out so they both become positive. How do I change a sign of something? I take a negative out. So there's that extra negative there, but I really don't care because now I got these guys which I can cancel. So my answer is negative this over this. The survivors, I just write down the survivors. Yes, ma'am.
So, when you decide to put a negative, to change the sign of something, the negative never goes away after it's done its job, it just stays up.
It would only go away if there was another negative somewhere to cancel it out, and there isn't.
So the answer has, okay.
The answer has to be negative. So this kind of thing, you see this kind of thing a lot, where you have like x plus y, x minus y, over y minus x. So what could you do there? There's nothing that's exactly the same.
X plus y minus.
Yeah, what is almost the same as this? That, not this, right?
Yeah.
They'd have to be the same sign, so it can never be different signs. But this guy, if I took a negative out of him, what would he become? Took a negative out, what does he become?
Negative x positive y.
Yeah, negative x, positive y. So it just really flips them. Do you see that? And now I can kill these guys. So my answer, if you want to, you could distribute that, make it negative x minus y. That's your answer. So if two things are offset by a negative, obviously when you divide them, you're going to be left with a negative 1. That's really all that says. Question?
Thank you.
So watch this real quick. If I did 5 plus 2, no Jeff, 5 minus 2 divided by 2 minus 5. There are two ways I could do this. I could take a negative out of the top and then cancel those and I get negative 1 as an answer. Is that cool? If these cancel, what's left? The understood negative 1 is left. How's that? So I took a negative out, so I turned those around. And now these cancel, so I'm left with that negative 1. The other way to do it is just what's 5 minus 2?
3.
And what's 2 minus 5?
Negative.
And of course 3 divided by negative 3 is negative freaking 1. Same thing, of course. It's just that when I have a variable here, I can't do this option. What's 5 minus x? I don't have a freaking clue. So I can't go this way and see that it's negative 1 easily. I've got to take a negative 1 out of one of them so I can see that these go away, leaving me with that negative 1. The same way these would cancel, leaving you with that negative 1. Same thing. Okay, maybe. That's the only part of this whole section that really is a little weird in its own right. Otherwise, you just factor everything and kill the ones that are the same. If they're almost the same except for a sign, you take a negative 1 out of one of them. And then they'll be the same. Kill them. Okay. So good question.
One more.
Okay.
80.
Oh yeah, 80. Let's see. 80's one that if you do it in the wrong order almost, you could drive yourself crazy. So I don't know if you guys remember what I said about if you have a cubes in a problem, what you should be aware of.
3 answers.
Well, if it's an equation, you might get 3 answers. But when you have a cube in a problem like this, you're going to have to get a little dude and a big dude. So if you see another part of the problem that's 3 terms, it might be related to the big dude. This, you can only do GCF. If you waste a lot of time trying to factor that, you're wasting time. Do you guys see what I'm saying? I mean, let's do the top first, actually, in this one. That's a cube, so what do I put down here? Little dude, big dude? Yeah. T cubed is TTT. 64, 444. So the little dude gets 1T plus 4 T squared. 16, and what's the middle term got to be? Minus 4T. And do you see how they're going to match up as long as what can come out of this? T. And you're left with T squared minus 4T. And then the big dude dies. Poor big dude. So that's my suggestion to you. If you see a cube in a problem, maybe do that first. So when you get that other 3-term deals, you can see that it's going to cancel maybe. So you don't waste time trying to factor it. It'll never factor. Am I done?
Yeah.
Cancel the T.
Now see, now I'm being evil. Yeah, I am done. And it's very evil of a math teacher to stand there like, no, we're not done. Yes, we are. So be careful. Why can't you cancel that T out?
It's part of an addition.
It's part of an addition problem, exactly. So you stop right there. In case you're interested, the only thing you could do here is you could rewrite this as T over T plus 4 over T. Do you see that? And then T divided by T is 1, but the 4 is over T. They both have to be divided by T. So for this section, let's not even do that. It's not even necessary. Yeah?
How'd you get a negative 14 on the second?
Down here? No, up here.
Yeah, right there.
Because the middle term is always
Opposite.
opposite sign of this. Because the middle term's got to be the cancellation dude. He cleans up the crap you don't want. Yeah. So those of you who are really able to factor pretty well, these problems are not hard at all. You just factor, 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 and then see what's the same. Kill them. Kill. All right, just don't kill too far. If you're not able to factor, that's the first step to be able to do these at all. So you have to come see me or get some help if you're still having trouble with factoring. Okay. Any other questions? It's particularly loud out here for some reason today. Of course, that door has a vent in it. That's great for blocking sound. All right. So any other questions? Okay. I think we just barely got into 7.4 last time. And the thing that I keep harping on is that anything you can do with numbers, you have to be able to do with variables, because variables are just numbers I don't know yet. So another thing I could do with these fractional numbers, like if I had 2/3 minus 7/15. So of course, what do you need before you can do this?
Greatest common denominator.
Well, the lowest common
Lowest.
denominator, yeah. Greatest one would be infinity, I would say. The lowest common denominator that I can make,
No.
3 is what they have in common. What can they both become? 15. 5 is what he needs. I like it. So we're all, so 15 is 3 times 5. So another way to look at it is what's he missing that he's got? 5. That's why the LCD is 15, because they can both become, he is 15, he can become 15. That's why that's the LCD. The only time the LCD is this times this is when they have nothing in common. Then they both need each other. Aw. You guys can be. So this will be, he needs a 5. So then I get 10 fifteenths minus 7 fifteenths is 3 fifteenths, which is 1/5 at level. So remember, the last step might involve reducing. All right. So what would this look like with variable expressions in it? They are excited out there. Let's see, what would it look like, Jeff? I don't know. Oh, well, it could be, no, I'm not going to be evil yet. That's right. You can do it, Jeff. There you go. So, do you see how this is a lot like this problem? Which one of these could I factor? It started off as a 3, right? So I could only factor the 15 to see what he's made of. I really didn't need to do that here because I could see that 5 times 3 is 15. You know, numbers I can kind of see a little bit better. My brain attacks them easier. Variables, my brain steps back and says, I don't know what the hell. There we go, should be. So I can't do anything with him, but I can certainly break him up. So then I can see what he's missing to make them both the same. That's the idea. It sounds too easy, maybe. Factor what you can, see what everybody else is missing, give that to them. It only makes sense. You're missing that, here you go. Right? So how do you break him up? Minus 8, minus 1, 11. Right? So now we can see a lot better what he's missing. They both have an x minus 1, so of course he's just missing x minus 8. So it almost seems too easy is what I think this is. You just give him what he's missing. Because now do they have the same thing on the bottom? Yes, they do. So now what am I allowed to do? Put them together. Right? I'm allowed to add these now that they have the same denominator. So what am I going to get on the top here? Minus 32. Plus 3x. All over what?
The x minus 8, x minus 1.
Exactly. Cool. The bottom doesn't change, right? We know that. I know that 1/2 plus 1/2 is not somehow 2/4 or something, right? It's 2/2. The bottom stays the same. It's sort of like making like terms. I have to make them, now they're like terms. 4x minus 8 of these plus 3x of these is 4x minus 30 plus 3x of these. They don't change. The bottom doesn't change once you make it the same. And the last step, just combine like terms, yeah. It's a cleanup step. 4x and 3x is 7x. How can I see really quickly that there's nothing that will cancel here? The bottom is factored. Can you factor the top? No. I can't do anything with the top. 7 won't come out of 32, so that's it. Nothing will cancel. Is there an x minus 8 on the top? No. Is there an x minus 1 on the top? No, so that's it. I know I'm done. Okay, how are we doing so far? Yes?
Why didn't you move the x minus 8 on top of the 4, like next to the 4?
What did I have to do to the bottom to make it the same? There was just an x minus 1 there. I need an LCD. I need the common denominators to be able to put them together. So what did I have to do here? I had to give it an x minus 8. I can't do that unless I also multiply the top. Of course, we know that. We have to keep it the same proportion. We can't change that. So if we do something to the bottom, we better multiply by the same thing on the top. Of course, right? So here, let me make something slightly more disgusting here. Let's see. If we can do this, let's see here. That is pretty gross. Cool. Good. I like to hear that. So the overriding thing that's going on here, math doesn't care what's in there. What math sees is a fraction minus a fraction. So in order to do that, I have to have like denominators. Now, as the humans in this case, we go, oh shit, to get like denominators is a little worse than normal because I got these variables in here. So I have to actually factor them so I can see what they're made of. Numbers I don't normally have to do that with, but here I got to do it. The math doesn't care though. The math still says the bottoms have to be the same for you to be able to do anything here. So the very first step on these, factor these. Seven and 4, good. Good, the bigger one's got to be negative. And then over there? Yeah, it's a thank God problem, right? X minus 7, x plus 7. So a good first step is, what do they already have in common?
X minus 7.
Yeah, they both have an x minus 7. So what's he need that he's got?
X minus, yeah.
Yeah, he needs the x plus 7. Well, that'll be a line. So I multiply top and bottom by x plus 7. Cool? What's the other guy need that he's got?
X plus 4.
X plus 4. He's got the 7 stuff covered, he just doesn't have the x plus 4 yet. So you give him. That step by itself, I don't care what the problem looks like, let that step be easy. As long as you can factor correctly, you can see what one is missing versus the other. The minute you give them both what they're missing, of course now they have exactly the same thing on the bottom, right? They both have those 3 things. So now I'm allowed to do what? Now, there's an interesting suggestion to maybe cancel these back out, but then I'm right back to where I was. Yeah, distribute and put your stuff together, right? It's going to be over what? What's going to be on the bottom?
X plus 4, same minus the same denominator.
Yeah, all this stuff here, right? Doesn't really matter what order you put it in as long as they're all there. And then on the top, I can start distributing this. The one thing you got to be careful about, and this is particularly evil problem, the minus in the middle. Let me see if I can give you a good way to do this. So what's in front of this guy? An understood 1, so I can just multiply him out. I don't have to worry about anything outside, right? In front of this guy is going to be -1. Shit! I've got to bring that negative through everybody, right? That's the thing you got to be careful about. When there's a minus sign in the middle of these fractions, you've got to be careful about the second dude. That minus has got to go to everybody. So when you FOIL this guy out, what do you get? 28x minus x minus 7 minus
3x squared
3x squared
minus 12x.
plus 12x 2x plus 8. Do you see what I had to do? That minus goes where? It goes in this whole thing. It's minus what? Minus this whole damn thing. So I've got to put it in front of this whole damn thing. So then what can I do with the negative on the next step? Distribute it. So the minus in the middle, you know it messes us up, that stupid minus, because people forget. When it's a plus, nothing happens. When it's a minus, everything has to change. They're exact opposites of each other. So I get 4x squared plus 27x minus 7 minus 3x squared. This would be 14, right? So it'd be minus 14, is that cool? I'm getting tired of writing, so I just want to do a couple things at once there. And now you just put your like terms together, right? So it's factor everybody on the bottom, give whoever what they're missing, put them together, and then it's cleanup. Cleanup meaning multiply it out, get your like terms together. All over. Now, of course, this is what you guys believe to be a long problem. I can let you believe that, but it's not. You have a little bit of stamina to get through there. What do you get on the top here? Good, 1x squared. Plus 27 minus 14, that would be 27 minus 14, 13, so plus 13x. Minus 7 minus 8, minus 15, over this business. And I was about to box this off because can you tell very quickly that the top won't factor? The only factors of 15 would be 3 and 5, that can't make 13. Or 15 and 1, that can't make 13. So I'm done. Nothing will cancel because I can't even factor the top to have anybody be a candidate to cancel. Done. Just that easy. Now, I want to be completely honest. I'm sort of trying to show you a certain way to do it so you don't make a very simple mistake. Right here, if you would have written this instead, let me do this. Can you guys let me write this down and see if you see where this is coming from? Let's see. Cool, is that all right? So that's this minus this all over the denominator, right? So here, what did we do? We foiled it out first. Here I'm just saying, what if we wrote that down there? What mistake do you think somebody might make?
I'm going to cancel stuff out.
And you can't because it's a subtraction problem, right? You can't put it there for a second and then go, oh, I really don't need them anymore. Goodbye, yay. I mean, it makes a really nice looking problem, but it makes it a very wrong answer. I cannot do that because that. So I must foil. I must get my like terms together because that's the only damn thing I can do. So be really careful. If you write it like this, you cannot just cancel that back out. It's like saying you never really need it in the first place. Put it there and now take it away. Ha. That can't be. That can't be how it works. Yeah.
So it wouldn't really make sense even if it was an addition to have.
Not even. Yeah, of course. It's not because it's subtraction. It's because it's not multiplication.
Okay.
Yeah. So division can only cancel multiplication. So if there's a plus or a minus, you're right. It's not the correct operation for division to attack. Cool. Maybe. It is a little bit better to write this because then maybe you won't forget the negative sign, but it's so easy. Believe me, we're all human. We desperately want to get rid of this stuff if we can. Just we're a little overly optimistic sometimes. All right, so let me give you guys a couple to try on your own. I'll be up front. One of these I'm going to give you is a very common place to make a mistake. So you're all like, oh, that didn't help out much.
And what part was that?
Yeah, you're going to have to figure that out. Thanks, Jeff. Let me see. I want you to start, yeah, okay.
Do you do anything to the second one?
Yes.
Bless you, bless you.
That's hilarious. He does that all the time. He sees us in the oven, he's like, oh, I don't know this. Funny.
It's not a quiz, by the way, it's okay to talk with people near you.
What'd you make? For the first one. Oh, number 4. You know? You just factor the bottom.
I did that part, I did the after.
Put them together. You put them together and then you have that. I don't think you can factor this, so I just kept it. I don't know though.
Two terms, they're both cut in half, x. You can't take an x out.
No, I don't think
You
you
still do put the parentheses, right?
Yeah.
So the x squared is x and x. 16 is negative. Instead of 16.5. I don't mean 8, I mean 16.5 because it's 4 times 4. So the squares. X plus 4, X minus 4. Now this one, the same kind of thing. They have to be 2 numbers that multiply by 16 but add to the 8. Yep.
That makes sense.
Multiply and add to the
I
end.
think,
Now you can see what he's missing and he's got, and divide what he's got. Yeah, he needs, think about it, he needs an X minus 4, top and bottom. Mhm. Let's see, he's got an X minus 4 and a couple of X plus 4s. He needs another fifth X plus 4. On the top, I love it.
One second, you didn't divide this.
No, no. Put in 1/7 minus 2/3. What would the LCD? Yeah, the LCD would be this times this, because they have nothing in common. These have nothing in common, so what's he missing? What's he missing? Yeah. Exactly. Then they would both end up with the same bottom. You can't add something to the top and bottom. You can only multiply. Yeah.
Okay. Check. Check this real quick.
So then you can maintain.
Get your like terms together. All right, guys. So this first one, how do you factor the bottom here?
X minus 4.
Minus 4 plus 4. Yeah, it's a nice little two-term difference of squares, right? Just cross them out because I put them there. Is that cool? What about this guy?
X plus 4, X plus 4.
You got to both be positive, so they add to be 8. See, the difference here is if one is positive and one's negative, they cancel out. There's a 0 in the middle. That's why it's only two terms. Here they're both positive, so they still stay alive at the end. Plus 8. So what is he missing that he has?
X plus 4.
Now he's got X plus 4 like crazy, yeah. So he's missing an X minus 4. And he's missing what? An extra X plus 4. He's got a couple, he's only got one, so he needs another one. Now I just desperately hope, don't make it more than that. I think on one level it might seem like that's too easy, so when you start doing it yourself, you start to doubt yourself, that can't be the way to do this. But the whole focus is make the bottoms the same. What's the easiest way to make that happen? Give whichever one is missing something, give it to them. And then the bottoms will end up being the same. So what do I get up here?
2x squared.
2x squared plus 8x. Now, remember one thing I told you you could do is to make this plus and negative. I think last time I got a resounding lack of reaction, so I wasn't sure what to make of that. So negative 3 times x is minus 3x. Negative 3 times negative 4 is plus 12, right? That negative has got to go to both things. Very easy mistake to make. All over all this business here, right? And the last step is almost always clear things up, right? Put things together. So you get 2x squared plus 5x plus 12 over this mess. And if you try to factor that, which you should, You'll get factors of what? 24 to make 5, and there aren't any. You might think 8 and 3, but they both have to be the same sign, don't they? So that would make 11. 2 and 12 won't work. 4 and 6 won't make 5. So yeah, I can't factor the top, so I stop. What can cancel? Nothing, because I can't even break the top up. So I'm done. Exciting, I know. But hopefully not difficult. It's okay for it to be a little boring, it's fine. It's better than being freaky. Now this one, not to pick on anybody, because I'm sure a few people did this. You cannot do this. And we know that. Right? Otherwise, 1/3 somehow equals, I could add 4 to both, so that equals 5/7. That's neat. We know the only thing you can do to the top and bottom is multiply or divide. So don't look at this as he's missing a +4. Neither of these guys has a 4. This guy has a k. This guy has a k + 4. Do they have anything in common? No. Don't say k. They don't have a k in common. If k was 3, play with me for a second. If k was 3, this would be 1/7 minus 2/3. Do these have anything in common? No. So what's the LCD? 7 times 3. He's missing him. He's missing him. So what does he need? K. And what's he need? K + 4. Now the bottoms are the same. Very simple looking problem that then you go, oh, that looks really hard, and then it ends up being really damn simple. You give each one of them the other dude, because they're missing each other. So here you get, on the bottom you get this business. Up here you get k minus 2k minus 8. The minus has to go through to both. So whichever way you can remind yourself that fact. If you want to, you can do this, and that makes it very simple to remember. All right, you make it plus and negative. Or not. Whatever makes it easier. And the last step here, what's the matter? Last step? Yeah, k minus 2k is negative k minus 8. Does anything cancel? Can it cancel those k's? Hell no. Good. So you can say hell no to me now. Please don't do it on a test, because then I'll say hell no and give it back to you.
So would the denominator be k squared plus 4k?
You could. But you never have to multiply the bottom out. Just keep it that way. It makes the last step easier. You can see if anything cancels easier then. So don't waste time multiplying the bottom back out. Especially, I mean, look at this. Do you really want to multiply? No. Thank God you don't have to. Leave it separated. All right, cool.
So is that the answer? The bottom one?
That's it? Yep, right there. Yes.
Yes, because if you were gonna be able to cancel anything out, you'd be able to see it.
Yeah, exactly. If you don't multiply the bottom out, you can see the parts, and you can see if any parts cancel. If you multiply it out,
Doesn't do anything.
yeah, now you can't see the parts. Yeah, good. Okay. So how do you guys feel about that so far? Is that all right? I got one vote for easy, so we'll see how the rest of you guys feel. Again, your vote is obviously going to be I hate it if you can't factor, because that's step number 1. One last one. Let me show you one last problem like this, and then we'll go to the next section. Oh, yeah.
For that, the top one, the 2 and the 12, you see how you put the little, to the right, to the right? No, to the right? No, to the right, to the right.
Yeah.
Yeah, and that's, you know how you put the 2 and the 12, you connected them? To the
2
right.
and the 12? Oh,
Yeah.
here.
Yeah.
Oh, that was because I was looking to see if I could factor it.
Okay.
So you'd have to do 2 times 12 is 24, but there are no factors of positive 24 that make 5. 8 and 3 would make 11. They can't make 5 because neither one can be negative. Okay. So what about, this relates to something we talked about earlier. This is 3. All right. this is still 7, 2.
So the denominator, you take out the negative and change the sign?
Yeah, in fact, not really take a negative out, but multiply top and bottom by negative. Right. In fact, I personally would probably do this one, because to me that looks a little backwards, because I'm used to having the variable first, right? So what if you multiply top and bottom by -1? What would happen? I'm totally allowed to do that, of course. I can multiply top and bottom of a fraction by anything except 0. So what would you get there on the second guy?
-2
-2.
over -7 plus x.
Good, so x minus 7. Right? 7 becomes negative, x becomes positive. Now I can put them together. 4 of these minus 2 of these is 2 of these. So see how it's just like the idea of like terms. You want to make the bottoms the same so that they're like terms. And you put the tops together.
So with an addition, if you're adding the two things and you want to multiply by a negative, you could pretty much just change the sign.
Yeah, just change the sign to a minus. Exactly. I like it. All right, so that section, none too evil. Again, another section which is pretty easy if you're able to factor. So I just want to do maybe 1.5 more sections, we'll see. So maybe we'll take a break if you guys desperately need one. Now, I'll tell you a little bit about what's coming for you next semester. If you take 103 or 110 here next semester, you're going to be solving equations that have these things in them. So you'd have an equation like 4 over x minus 1 plus x over x squared minus 1 equals 3 over x plus 1. Stuff like that. So the funny thing, I don't know if you remember, if there were numbers on the bottom, do you remember what you could do? Can't you multiply by the LCD? That would destroy everything? Well, like I said earlier, whatever you do with numbers, you also do with variables. Can anybody see what the LCD would be here? What's this, if you break it up? X minus 1, x plus 1. So the LCD would be x minus 1, x plus 1. So if you multiply everything by x minus 1, x plus 1, here the x minus 1 would cancel, here the whole thing cancels, here the x plus 1 cancels, you get a single line equation easy. Okay, so that's all I want to say about that now. You don't have to worry about that yet. That's in your future. Okay. I honestly can't believe it is so close to the end of the semester. That is insane. Remember when you were 7 and summer lasted several years? It seemed like summer, and then they say school. School? Oh yeah, I remember school. And now it's like, bam, it's gone. So 8.1 is all about roots. If you want to say it my Georgian dialect, but roots, like square roots, cube roots, things like that. So let me try to see what you guys already know. I think we've done a couple of things like this before. When we do difference of squares and cubes, we are doing roots. So for example, what's the square root of 49?
7.
And how do you know it's 7? What do you think in your head when they give you that problem?
7 times 7.
What times itself is 49? So it's the square root is a very strange function. I'm not really doing something to 49. I'm thinking backwards. What would have gotten me to 49? So we hit a few functions like that. One function that we're not going to talk about this semester is called a logarithm. So if any of you guys have ever heard of that, if you haven't, you're like, what the hell did he just say? And it's the same thing. It's what gives people trouble because you got to think backwards. Now roots we're a little more familiar with, but you realize that's exactly what you do. You think backwards. Who could figure out what about if I do this to you? Cube root of 8.
2.
And why is cube root of 8? 2 because it takes 3 2's to multiply to be 8. When I write the symbol down, what's understood to be in here? a 2. And since it takes 2 sevens to multiply to be 49, that's why the square root of 49 is 7. So can you imagine, I could certainly put larger and larger and larger numbers up here. You just got to keep breaking these down into more and more and more pieces. Are you semi with me? What about the cube root of 125? See, now that's one you know from doing the cubes in the factoring section, right? It takes 3 5s to make 125. Cool. What about, how about this one? Square root of, here's a little evil, negative 16.
Negative 4?
What's negative 4 times negative 4?
Oh, it's positive 4 there.
No, what's 4 times 4? Is there any number multiplied by itself makes negative 16? Ain't no such number, right? Ain't no such real number. There are things called, I think I've said that before, there are things called, unfortunately, imaginary numbers. This is not real, so the answer here would be not real. Can you guys see that? What's the square root of 16 by itself? 4. Why? 4 times 4 is 16. Square root of negative 16 cannot work, because anytime you multiply a number by itself, it's got to come out positive, right? If it's negative, times negative is positive. If it's positive, times positive is positive. There's no way. So if you take a number, give me a number, any number, positive or negative. 9. What's 9 times 9? What about negative 5? What's negative 5 times negative 5?
25.
See, you can't possibly get a negative. So this is asking you to think backwards. What did somebody multiply by itself to get negative 16? Ain't a damn thing that I know of yet. It's not real.
So any negative square root is not real.
Beautiful.
Correct.
In fact, it even goes further than that. Any even root, if it's the 4th root of negative 16, not real.
The 6th root of negative
But
16.
what's the 4th root of 16? 2. Why? Because it takes 4 2s to multiply to be 16. Do you guys see that?
Mhm.
And if you're not sure, like here, let me give you one that's a little freakier. Which one? I don't know. Jeez. 4th root of 625. What do you start doing? It's all about seeing the parts of this, so you start breaking it up. What definitely goes into 625? 5. So 5 goes into 62, 12 times, and then 25, 125. And then 125, 5 times 25, and then 25. So what does it take 4 of to make this? So the answer is 5. Good. So roots always cut things down. Right? It always says break it up into this many parts and give me one of them. Give me the representative thing. So since it takes 4 5s to make this, the 4th root of 625 is 5. Yes, ma'am.
Are they only even, or is there odd roots?
No, there's odd roots. We did a cube root.
Oh yeah, okay, so if it's the odd root, wouldn't you be able to have a negative?
I love it. So that's exactly where I'm going. So my purpose here, my point of doing this here was, if I had the 4th root of negative 625, that is not real. Can't do it. Because anytime I multiply something by itself 4 times, if it's negative, the negatives all cancel. So it can never come out negative. But a cube root of like negative 27, I can do that. Because when I multiply a negative number times itself 3 times, the negatives cancel here, but they're still alive there, aren't they? 3 negatives multiply to be a negative. Sorry. So what's a cube root of negative 27? Negative 3. I love it. I'm not sure what that's. Because 3 times 3 is 27, and if they're all negatives, there's one negative left alive, so that's negative 3. So let me see, what about this guy?